Hi, this is Alex Pault here at the Embedded World Show in Nuremberg, and I'm here with C.S. Lin from Winbond. And well, obviously we're talking about embedded, but well, security is important as well, isn't it?
Yes, it's very important, yeah.
Well, and the funny thing is that up until a few years ago, security was, yeah, maybe. And then it became a buzzword, hey, we have security, but what kind? And now security is really a critical application space, wouldn't you say?
Yeah, actually, right now it's very critical to the system because hacker can go through this, hack one of the device and kind of risk the whole entire systems.
Exactly. Now, I notice you have two boards here that are for endpoint security. Can you explain these devices for me?
Yes, let me introduce first. One is called Max 1000, which is called IoT maker boards. And basically, Winbond integrates security into the memory device. So we utilize the memory device to do the authentications, which means to turn the maker board to a trusted device, which means allow host to identify the board first before he access the data. So which is very important for the securities.
Well, and that's the key because it's not enough to just simply say it's secure. There have to be ways of backing it up, verification,
right,
certification, and you supply that information as well, correct?
Correct. Basically, it's just like when you're passing the airport securities, you need to show the passport. Basically, our device provide the security keys, which is for the host and the Fresh to do the authentication, to recognize each other, to trust each other before they're doing the further interactions.
Exactly. So by doing the authentication they create the secure link that you could work with forward.
Correct, yes.
Excellent. Now, what about this board here? It says Security Winbond Authentication Flash. Tell us a little bit about that board.
Yeah, basically, this is the Spy Flash. We integrate the security into the chips. It provides the four secret keys, will allow you to bind with 4 different hosts. This is how they establish the trust. I give an example. Basically, for these IoT maker boards, the local Max 10 host can establish the trust between the Flash. And if you put this IoT board into the internet, basically you can use your phone to establish a link with that board also. So which prevent the hacker try to replace the board.
So a hacker, you can actually control the board from externally, securely, with your cell phone.
Correct. To do the authentications.
For the authentication, so that way, even if the system is an open system, hackers can't get in.
Right. For example, how can I tell if I use my phone, only I hold the key will be able to access to that IoT board. But for example, if you are a hacker, you are trying to hack the board, but you will not pass the authentication that embedded into our memory device.
Got it. So the actual authentication is at the hardware level in the memory.
Yes.
So it prevents, obviously, tampering.
Right, that's correct. And the second board actually is even more. This is for the IP camera. Basically, it's, for example, the baby monitor. So people install the baby monitor at home, right? So the parent like to monitor even at work. But how can you make sure the person who log in is, no
one else can see it, nobody else.
So that's which means that only parent, they hold the same key as the baby monitor are able to get access to the camera and see the live video.
Right, so without the access keys, nobody can get in.
Basically, for example, if I'm a hacker, I try to sneak in, try to look at your camera, which is I was not able to because I don't have the keys. I will not pass the challenge response was conducted by our Flash.
Excellent. Now, what about physical security? If I have access to the device, what protections keep it safe from me?
Basically, as I mentioned, our device has 4 keys, and the keys is actually implementing OTPs, and only doing one times. And once the key is provisioned, by all means, there's no way to read the key out of the device. Which if even hacker open the device, you will not be able to see the keys.
Very nice.
The most important secret between the host and the device.
So the keys are protected regardless?
Yeah, it's protected regardless, yes.
Excellent. Now, I understand you had another board you wanted to talk about, but your colleague was going to step in for us.
I invite my colleague to introduce the third board, okay?
Thanks, CS, I appreciate it.
Nice to meet you. Okay, thank you.
Hi, Takahiro.
Yeah, thank you.
Have a seat, and I understand you have another board for us.
This is the board for the SPI stack. Originally, this board is in the flash memory and USB memories. Then you boot from the flash memory, and the Linux kernel part is in the USB memory. But this board is in the only one serial flash. This is the SPI stack.
Okay.
This is the NOR flash and serial NAND into the one packages.
Right.
So the feature of this board is to remove in the USB memories. This is a very cost-effective solution.
To protect USB memory.
Yes, to remove the USB memory. Originally, this board needs the USB memory on this portion, but this board do not have the USB memory.
Right. There's no. Okay. Oh, there is no memory.
Yes,
No
but
memory at all.
this board can work because this is our Winbond technology, SPI stack.
I see. So the stack is in the chip.
Yes.
The USB doesn't have to have any memory, and
Correct.
it prevents hacking.
Correct.
Excellent.
Yeah, Winbond have the serial NOR flash and serial NAND. Then this is the only one package in the serial NOR flash and serial NAND. So that can work in the only one packages.
Right.
And
So you can use a secure USB port.
yes, you're right. Yeah.
Excellent. Now, so that would actually also fit for a lot of different applications, secured terminals, kiosks, anything using USB, correct?
Yes. For example, in some applications using NOR flash and the eMMC, then the eMMC can be removed to using the SPI stack because this have in the serial flash and serial NAND, and serial NAND portion is removed, can be removed from the eMMC. Yeah,
Excellent.
yeah, that is our features.
So, and what are the other advantages? If I remove the memory from the USB, does it give me any other advantages from security?
No security. This is for the cost-effective solution.
It's a cost-effective solution.
Yes.
So, and so it's to save the money on the memory that's used
Yes.
in use. Got
Yeah.
it.
Here the engineers consider to use in the USB memories for storing the Linux or some graphic data. But the SPI stack can remove to the USB memories because this have the NAND flash inside of this
Inside
packet.
of it has
Yes.
it.
Yes.
I get it now. Yes.
Yeah.
I see. I understand now. Okay, so this has all of the memory, the flash, everything needed to drive the USB, so that way the USB doesn't need it itself. Got it.
Thank you.
Well, thank you. I appreciate it, Takahiro, for taking the time to explain all of this to us. And they can go to winbond.com to find more information?
Yes.
Excellent.
Sure.
Well, and thank you very much for taking the time today.
Thank you.